Thank you, Angela, and my apologies for calling Alison all morning. I don't know what came over me. So, yes, my name is Jon Hutton. I work for UNEP, and I'm Director of the World Conservation Monitoring Centre, which is based in Cambridge. And at this point, it's tempting to be somewhat glib and facetious about the relationship between the two universities, but it would not only be quite rude, recognising the wonderful hospitality from Merton College here in Oxford, but it would also be a very poor career move because my boss, Achim Steiner, was at Oxford. So what I'm going to talk to you about today in 15 minutes is something to do with scenarios around biodiversity. Much of what I'm going to talk about is to be found in this document, which is the Third Global Biodiversity Outlook, which I commend to you. And behind this document, which I think does contain expert scientific opinion in a readily accessible way, but behind that lie a number of scientific studies, such as this one, which is from the Biodiversity Indicators Partnership, and which came out in Science last year, and also the one on scenarios by a similar group of people with the lead author, Enrique Pereira. And our institution works on these types of things, and we provided the facilitation, if you like, the secretariat for these initiatives, as indeed we did for processes like the UK National Ecosystem Assessment. Because Angela told me yesterday that she was a tough chair and she would cut me off if I overran, this is my conclusion. They say there was a scenario there and I responded to it. Enrique, the conclusion in the paper is that quantitative scenarios are coming of age as a tool for evaluating the impact of future socioeconomic development pathways on biodiversity and ecosystem services. That is undoubtedly true, but a statement like that usually is followed by a big but, and it's the but that I'm going to be addressing now. So what have we been doing historically in our sector, by which I think broadly mean conservation scientists, conservation biologists and others? Well, in the past we've developed relatively simple models based on extrapolation, and that gives us a range of values which is either based on trends from today or sometimes in the past, but very rarely in the deep past, which is why, in fact, the work that Kathy is doing with her colleagues is so important and is really underused today in ecology and climate for some bizarre reason. I hope you can change that, Kathy. We've also dabbled quite a bit in horizon scanning, and there is a growing interest in this and a lot of value to it, but it has to be admitted, I think, certainly from our institutional perspective, that we haven't always been very good at this. And the reason I say that is if you look back and see the things we did predict on the horizon, we missed most of the big important developments as a community. But more importantly, we're now using scenarios and associated models following the sort of lead of the corporates, particularly people like Shell, over the last couple of decades. And this is how, as a community, we tend to do it. First of all, we develop these scenarios and the storylines that accompany them. And we do this to try and get an idea of where the key, the key indirect drivers of biodiversity loss, what they will do, things like human population growth, greenhouse gas emissions, etc. Thank you. Every biodiversity scientist should have hay fever. It reminds you that there is a downside to biodiversity. So we use the scenarios, and the sorts of processes that they've been included in are the Millennium Ecosystem Assessment, things like the Fourth Global Environment Outlook from UNEP, and work from the various subcommittees and working groups of the IPCC. We then take those scenarios and their projections of things like human population growth or greenhouse gas emissions, and we feed them into various models which turn the indirect drivers into direct drivers. So things like land use change, the things that we know impact in particular on biodiversity, various climate change scenarios at different scales. And we do that through climate models, which you all know about, but also something called image, which some of you may not be familiar, which is a model which was built and which underpins a huge amount of the work that is done, not only on biodiversity, but more broadly today, and I'll come back to that in a moment. And then finally, once we've done all that, we take those direct drivers, in other words, what might happen to land use change, and we feed that into biodiversity models. Those may be relationship-based models or process-based models, and they're at different scales. So you can have simple species area models, dose response models. You can have more ambitious models, such as the sort being favored by the climate change community, the dynamic vegetation models. But the one which is most embedded, I suppose, in international processes is something called GloBio, which was largely developed in the Netherlands, which is embedded in processes like GEO and GloBio and the Millennium Assessment. So someone said earlier, I think Angela, that the scenarios and the models are interlinked in a very complex way. And it shouldn't be surprising that a lot of people, including, I find, some of the people involved in these, don't really understand how all this fits together. And then finally, I would like to mention ecosystem service models because, of course, everyone's interested in going beyond biodiversity into ecosystem services. It's been quite clear over the last 24 hours. This work, I think, is very, very much in its infancy. I'd like to take each one of these steps now one by one and just give you an example of a practical example of how it's been used. So, for example, scenarios. UNEP's Global Environmental Outlook, the most recent one, developed a range of 4 scenarios. I think their names are perhaps self-explanatory. Those scenarios were then taken and they were fed into the second stage, which was the image model. And out of that came a range of direct drivers of change. Things like, for example, the sorts of carbon emissions we might expect from energy and industry, and you can see there very different projections depending on the different storylines. And then that information was fed into the biodiversity model. In this case, it was the GloBio model, in which, again, we are a partner, but we recognize its shortcomings. And now that produced these sorts of maps, which I hesitate to call projections, but they're sort of what might be the outcome of these processes in 2050. And in this case, because it's linked to land use change, land use actually explains about 80% of the variance in our projections on biodiversity. You can see where the greatest changes might be expected. So that's fine then. Is that all working? Well, I wish it was. At each of these stages, there are major problems. There are many of them, but I'm only going to mention a few stage by stage. So the first one is related to scenarios. You've already heard, scenarios have been developed to provide alternative views of the future and all those other things. They help our thinking around the future. But it is stressed that they're not predictions. And one of the shortcomings is that people who are developing these things tend to believe in their own scenarios. And more importantly here, they should at least be plausible. So the Millennium Ecosystem Assessment, which I think was one of the best efforts so far, came up with 4 scenarios with 4 separate storylines, which many of you will be familiar with. If not, I mean, they're available online. And I think they were broadly plausible. However, there have been other efforts to create scenarios which perhaps are less plausible, and I'll just use one, and I won't mention the institution, but I will read out scenario 3, the new zoogenesis. Here, bioengineering runs amok. Conservationists find themselves in an increasingly bizarre circus-like environment. Religious fundamentalists attack bioengineers for claiming the throne of God for themselves. Now, I don't know about you, but I find that a slightly more implausible future than some of the others. And so in the endless world of scenarios, it does rather beg the question about how you choose the 4, if you like, or 5, or however many you want, to work with. And it's not at all clear in our sector how you go about that in a sensible manner. Moving to the second step, when we get to the models like image, many of these models, including image to a large degree, are black boxes, we take it on trust that they have been verified and that they are sensible. There is a handbook with image. It's about that fat. I don't know if anyone's actually read it, but there are clearly problems there. The second is that most models don't agree. I mean, in the climate change world, with over 20-odd models, we commonly take an average, and I'm not sure how useful that is. Next, models are commonly not tested. More importantly, they don't learn, partly because they're not very often updated. And finally, they don't have any room for feedbacks. Why is that important? Well, it's important because biodiversity is full of non-linear processes, perhaps best known from climate change, things like freshwater eutrophication, and you're all familiar with the term tipping points, but none of these are actually included in any of these models. So as a result, scenarios and the models can generate results that are very hard to interpret. Minicam, for example, depending on which scenario you've got, we could be increasing the amount of forest by 2050 by 25%, or it could decrease by 50%. It's really quite difficult to use this kind of information in any sensible way. So finally, biodiversity models. Well, the field of biodiversity metrics, as you heard from Simon Stewart, is fraught. Different characteristics of biodiversity respond to climate change at different rates. There are no standards, and they're very rarely comparable. This is a matrix generated by Georgina Mace, who's the doyenne in this sector. All I want to say there is that these are the kinds of things we might want to measure, but in fact data for all of these is really rather poor, so we end up using things with incomplete data or things that don't make a lot of sense. And then on top of that, we may be looking at the wrong metrics anyway, because it may be about how things are aggregated. The Millennium Assessment told us that it's not species richness that's actually important to resilience, but a thing called response diversity, which is all about how species come together in functional groups and in communities. So are models and their results at all relevant? What does it matter if we have a decline in something called mean species abundance? I mean, if you've got 10 minutes in the room in the Oval House, in the Oval Room in the White House, what would you tell Barack Obama that mean species abundance means? Similarly, if we talk about threatened species, what's the relationship between threatened species and ecosystem services and human welfare? Now, the reality is that land use change does explain about 80% of the variance in biodiversity, at least from these models and scenarios. And in land use change, agriculture is the biggest driver at the moment. And I think you're all aware it's likely to become an even bigger driver over the next 10, 20, or even 30 or 40 years. And so the reality here is that we better find out what the relationship between biodiversity and ecosystem services is, because we need those arguments pretty quickly. There isn't a whole lot of time. So in conclusion, where next? Well, yes, our use of scenarios and models is becoming more sophisticated, and we're beginning to start a discussion around those so-called what-if questions. But we need to understand the relationship between the drivers and biodiversity a whole lot better than we do now. We need to start looking at interactions and feedbacks a whole lot more carefully than we are now. We need better standard indicators, something was mentioned this morning. That might need better data. I'm not sure we've got time to collect it. Benchmarking might be a complementary or an alternative option. And then finally, we really need to work out how to link biodiversity and ecosystem services. And even the approach taken, this is my final comment, even the approach taken by the UK National Ecosystem Assessment borders on the absurd, because we make the argument as a community that biodiversity underpins ecosystem services, but then we also measure biodiversity as a product of ecosystem services, which doesn't make a whole lot of sense. And we seem to be wanting it both ways. I'm sure that if Bob Watson were here, he would shoot me down, possibly literally, but that's what I think, and that's why I'm ending. Thank you very much.